Here we go, here we go, here we go, here we go. Parallel lines never cross. Parallel lines have the same slope. Y equals 2x plus 1 is parallel to. Y equals 2x plus 4. They have the same slope. Next step, and perpendicular lines cross at right angles. Perpendicular lines have negative reciprocal slopes. Okay. For y equals 2x plus 1, take the slope 2 and flip it to 1/2 and change the sign to negative 1/2. So the line y equals negative 1/2 x plus 3 will be perpendicular. So you've done it, now you know you done good. Yeah.
Hey geometry students, so there you have a little bit quick video that we're going to be talking with 3.5 here in Big Ideas about how to write these equations of parallel and perpendicular lines. So essentially that video was kind of showing you a bit of what we're going to do. We are going to be doing that, but also before we even get to writing those equations for the parallel perpendicular lines, we're going to be identifying just the fact that if we have parallel perpendicular lines based on the type of slopes that we are given. And even before that, we're going to actually look at some directed line segments. We're going to use slopes to partition directed line segments, and we'll see what that's all about here in just a minute. First, let's quickly go to our little cartoon, a little football cartoon today. So here you have the coach on the sideline saying to his other coach here, "They're going to punt. Release the special teams." As the special teams are in a cage down underneath, like they got to be caged animals. You can see them, special teams coming out on the field. So obviously we have a offense, a defense, but there also is special teams on a football team. If you're not familiar with football, there's a whole team just for the special, they're going to punt situation kind of thing, or kickoff situations kind of thing, special teams. All right, let's get into our 3.5 lesson here. So let's first go, what is a directed line segment? And that's where we want to go to page 88 and where your vocabulary is, a directed line segment here. So a directed line segment AB. So if you have a segment AB, you can draw A and B and connect the dots and make segment AB. But essentially you're going to write down this here for our directed line segment. It is a segment, so it's a segment that represents moving from point A to point B. That's what basically it is. It's a segment that represents moving from A to B. So you go from A to B. The following example shows you how to use slope to find the point of a directed line segment. But we're going to get into that here in just a minute. Okay, so here's the example that we can identify how to find a point on a directed line segment. It says find coordinates of point P along the directed line segment AB so that the ratio of AP to PB is 3:2. Now this is a very challenging question, I'll give you that. It can be very confusing here to do what to do here with this. So this one shows you that the actual graph here, shows you the points on the graph. Now you can do that. It's only going to give us this though really on our assignment. It's not going to show us this, but we could do this first. We could draw it out and see a picture of it, and that might be helpful to you. Definitely want to draw a picture of the line. It doesn't have to be necessarily on the coordinate plane. So the first thing you want to do is kind of break this up into a 3:2 segment. So if it's 3:2, that means there are 5 broken up pieces, 5 equal pieces here on the segment, and the point P is going to be on, there's 3 this way, 2 that side, so it's going to be kind of in the middle here, sort of on this side. So that shows you kind of where it is at. Once you do that, then you want to figure out the slope of AB. First of all, you need to figure out what that slope is, and so they're doing that. They're figuring out the slope here, and so they figure out the slope is 6/3 as far as rise over run. So they're going to subtract the y's over subtracting the x's to do this, and they don't simplify it to 2. Notice 6/3 we know would equal 2. Our slope would be 2, but you want to leave it in rise over run fashion here as 6/3. And now what we need to do here is we need to see, okay, if our 3:2 segment, we're going to have 5 little pieces here on this segment broken up, and our P is like on the 3rd one here. And so it's going to be 3 this side and 2 that way. So if you think about it, it's out of fifths. So it's really 3/5. You can see here that the fraction 3/5 is where this is as far as where is P. It's 3/5 of the way of the segment. It's basically 3/5 of the way from A to B, and that's what the whole directed line segment is about. It's going from A to B. So your P is 3/5 of the way from A to B. And so now what we do is we take our rise over run numbers and we multiply each of those numbers by the 3/5. That's what they're doing here. They're starting with the run. They start with the bottom number here, the run number. So they're saying 3/5 of 3. They're going to multiply that, and they get 1.8. And they do the rise number with 3/5 of the number 6. They multiply that, and they get 3.6. They now take these numbers, and to be able to figure out what point P is, that's what we're trying to find. It says find the coordinate of point P. We're going to take our coordinate for A, and what we're going to do is we're going to add in these numbers here, these decimal numbers. So remember the run, that's your X number, right? It's rise over run, but it's the change in Y. Y is on the top here. That's why they chose to do run first. That's your X number. 1.8 is going to add to 3. 3.6 will add to 2. That's what they're doing down here. Yeah, 3 plus the 1.8, 2 plus the 3.6, and that gives them this coordinate here, 4.8 and 5.6. And so now you can see where they put that there. That's 3 to 5, or 3/5 of the way. P is 3/5 of the way. It's a 3 to 2 ratio. 3 on this side, 2 on that side, and there's P. All right, so let's go ahead and try that on our extra practice. Okay, so looking at our page 89, our first 2 extra practice asks us to find the coordinates of point P along the directed line segment AB. So that means you're going to go from A to B, so that from A to P and to P to B is the given ratio. So here's our points A and B. Now we can plot this on a coordinate plane, but we don't have to. I'm not going to do that this time. And our ratio here is a 3 to 2. So first of all, what you want to do is draw a segment. So you're going to put points A and B down, and then draw a segment there for that. So I did it right above here. So I put a point and then label the A, point, and B, connected that with the blue line. And now the next thing we want to do is see, okay, it's a 3 to 2. So you add these two numbers together. 3 and 1 make 4. That means you have to have 4 sections here, 4 equal sections on the segment. You're going to have 3 marks, okay? You will have 3 marks, 1 less than 4. Not necessarily always this number. It's just 1 less than the added number together. So it's 4 here of sections, but there's really only 3 tick marks. So you can, what I would do is put the 1 right in the middle, because if there's 4, it's got to be equal. So right in the middle, that cuts into 2 halves, then right in the middle here, and right in the middle there. That makes 4 equal segments there from A to B. Okay, so now the next thing we're going to look for is what fraction do we need to multiply? If our ratio, so our P actually is right here, I actually put that down. I'm going to mark off P because it's going to be 3 to 2. So we have from A to B, it's got to be 3 and then a 1. So 3 to 1 means you have 3 and then 1 to B. So P has got 3 on this side. From A to P, it's 3. And then from P to B, it's 1 segment here. So that's where P would be. And so if that's the case, then it's going to be 3 out of 4 segments. A is 3/4 of the way, or P is 3/4 of the way from A to B. So if you go from A, this is 3/4 of the way from the whole segment. So 3/4 is the fraction we want to focus on. So that means we want to multiply by this, we want to multiply the slope number by 3/4. Essentially, that's what we need to do in which we get our slope. So now that's the next thing to do is find the slope. So we need to do the change in y over change in x, or the subtracting the y numbers over subtracting the x numbers. Now you can do, y2 minus y1, x2 minus x1, or I just usually do the first point minus the second point. It doesn't matter as long as you're consistent, and these are the same. They're from the same point, and these are from the same point. So we start off with our slope here. So I'm going to make a fraction out of this. On the top, we got to do the y's. So it could be 7 minus 1 just on the top there, or we could do 1 minus 7 like I showed you here. So it doesn't matter which way we do. We could do 7 minus 1 or 1 minus 7. Either way would be fine. We just have to be consistent. So if I'm going to be consistent and do it from 1 minus 7, I'm going to have to do the next one as -4 minus -2 on the bottom. That's consistent. And 2 negatives are going to make a positive here, so -4 minus -2, 2 negatives make a plus here. And so now when we simplify the slope, this is going to be negative 6 on the top. This will be a negative 2 on the bottom. So negative 6 over negative 2. And so that's going to be our rise, and that's going to be our run. So our rise is negative 6. Our run is negative 2. Now, we can also make these positive. If we had done this the other way, it would have been positive 6 over positive 2, and that would have been fine. So now let's focus on the run. Let's focus on the x number down here. This is the negative 2. So we got to multiply this negative 2 number by our 3/4. This means multiply the slope, the rise over the run, by 3/4 each one. So 3/4 times a negative 2. And so when we multiply that, we're going to end up with getting negative, we got 6 over 4, basically. So negative, it's going to still be negative here. So negative 6/4, if I say 3 times 2. And then we can reduce that to negative 3 over 2, which as a decimal is negative 1.5. So we can do negative 1.5 from that. The next one we want to look for is the rise. And so we're going to do our rise here with our negative 6. Do the same thing, 3/4 times negative 6. And so we can multiply this together here. That will give us a negative 18 over 4. And we reduce the 18/4 into 9 over 2. So negative 9 over 2 as a decimal is negative 4.5. We want to get these as decimals. It makes them easier as we're going to add them to our A number here, our A point. So now that's the next thing to do. We're going to add to point A to find point P. So we're going to add these each here. So our rise and our run. So our run is going to get added to the x. The rise gets added to the y. And so our negative 2 here. So as we put our point P down, our big ordered pair, we're going to have negative 2 plus a negative 1.5. So negative 2 plus negative 1.5. So that ends up being, we'll see what that is in a minute. And then we're also going to do the rise here, the 7 plus negative 4.5. So 7 plus negative 4.5. So that gives us a point of negative 3.5, comma 2.5. So here's what we could do to check ourselves. We could plot these on a coordinate plane and plot the P and just make sure that P is on the segment and it's 3/4 of the way from A to B. That's what we would need just to make sure to check that. All right, so on problem 2, we'll start the same way. We're going to just first draw a segment out with A and B on it and draw a line there, so it's in blue. And then we're going to see how many marks do we need to make on here, and you can see it's 2 to 3. So first add these two numbers together. That gives you 5. So 1 less than 5 would be 4 equal marks here. So we need to make it 4 equal marks. So that means there's going to be 5 equal segments. So just kind of do your best at figuring out where that's going to be, because it's not, you can't just go straight in the middle here. It's not an even number. So in this one, you're going to have to say, okay, I'm going to go about 1/5 of the way here, 1/5 of the way here, 4 marks. Just try to make them as equal as possible. I mean, the idea is is to give you something you can go off of. And then we're going to put the P 2 marks in. So right here, 2 to 3. So 2 marks from A. You're going to put point P there on that mark. So that gives you 2 on this side and then 3 from P to B. So 2 from A to P and 3 from P to B. That's where we essentially are. So that tells you that that point P is 2/5, because there's 5 segments here. There's 5 little segments it's broken up into. 2/5 of the way from A to B. That's where our P is at. And so 2/5 is the fraction that we need to multiply by. That's the fraction we got to focus on when we get down to finding our rise over run. We're going to multiply the rise over run each by a 2/5. So now we need to find what that rise over run is by using the slope, finding the slope of the numbers here. So for AB, our slope here as a fraction, we'll start with our y's. So negative 2 minus 1. Again, I'm starting with this one minus this one. So I'm starting with B minus A. So negative 2 minus 1. And so that's going to end up giving me, well, we'll see what that'll give me a negative 3. But let's do our next one here. I got to do negative 8, or I got to do 8 minus 3, not negative, but 8 minus 3. I can't do 3 minus 8 because that would be the wrong way. We're doing B minus A. That's what we're doing here. So we got to stay consistent and continue to do B minus A. So that's 8 minus 3. If I turned it around and did A minus B on the bottom, well then that's going to be a problem. All right, so At that point, we're going to see -3 on the top and 5 on the bottom. So we're going to see our rise is -3, our run there. So rise is -3, the run is 5. And so now we take each one of these individually and separately. So we're going to first start with our run. Let's go ahead and do the run again. So what we have to multiply the 5 by is the 2/5 fraction. So 2/5 times 5, you can actually cross cancel the 5s there and see it's just going to end up being 2. So 2 is the number we're going to add eventually to our A. And then if we do the rise, 2/5 times -3 for this one. And so that's going to end up being a -6/5 as I multiply 2 times 3 here. And so then I got to do this. I got to basically do -1.2. Make this into a decimal. 6 divided by 5 is 1.2. So now I need to add these to so I need to add to point A to find point P. I need to add these to point A in order to find point P. So let's mark our point down. So P is going to be this ordered pair. So the rise is the X number. So 2 plus 3 there for the X number, or 3 plus 2, it doesn't matter. We're seeing it's going to end up being 5. And then for the rise, it's going to be 1 plus the -1.2. So our number here for A plus this number here, -1.2, that will give us our point here for P, which is 5 for the X and 0.2 for the Y. And again, we can always check that by drawing this out and plotting these points and just making sure that definitely is on this segment, and it is basically 2/5 of the way from A to B. All right, so on page 88, you see the theorems there. These are 2 theorems that are talking about the slopes of parallel lines and perpendicular lines. And for parallel lines, we know that they have the same slope. That's what that video was talking about at the beginning. So right there, they have the same slope. You want to highlight that part. Parallel lines will always have the same slope. So the slope of the blue one will be the same as the slope of the red one. And then for perpendicular slopes, it also kind of talked about it there as well. This one says that their product, the product of the 2 slopes, if you multiply the slope of the blue one times the slope of the red one, it equals -1. So that's true. So you can do that. But also, and the video said this as well, I like to think of it as this: opposite and reciprocal. The opposite sign and reciprocal, they said negative. I usually like just saying opposite because you might start with a negative and then you have to turn it to its opposite, which would be positive. So just opposite sign and reciprocal, that's what the slope has to be. So if you were to multiply opposite reciprocal slopes together, then you would end up getting this -1. All right, so back on page 89 for your extra practice, number 3, it just says determine which of the lines are parallel and which of the lines are perpendicular. So we want to look at their slopes to be able to figure this out. So we just start to go through the lines here. Now these lines are all named here. You can see the names are over by the arrows. We got this line, here's Q, here's P, R, S, and T. So we have 5 different lines, 3 kind of going this direction, 2 going this direction. And so we'll just start with one of them. Let's start with line P. So line P, we need to figure out, okay, what's the slope of line P? Now it does give you these ordered pairs that are in there, but since it's on a coordinate plane, we can just go ahead and do the rise over run. So our rise, if I start from this point up to that point there on P, I'm going to rise 1, 2, 3, and also run 1, 2, 3. That's a +1 slope. 3 over 3 is 1. So our slope for P is 1. If we want to go to line Q next, we can go to line Q, do the same kind of thing. So here's a point, and there's another point. So we go 1, 2, 3, going up, 1, 2, 3, going right. So also 3 over 3 is also 1. So we have line Q is also 1. Let's go to these lines over here. So line R. So we want to do a rise over run this way as well. Now these are all going downhill. So we know these are going to all be negative slopes here. These last 2 we're going uphill, so they're positive slopes. So if I go from this point here, I can rise 1, 2, 3, and then run 1, 2, 3, 4. So it's a negative number, and our rise is going to be up 3, and then over 4, it's a -3/4. And so then for the next line, line S, on this one, we can look at this point to that point. So 1, 2, 3, 1, 2, 3. So that's going to be also 1, but it's a -1, so it's going downhill here. So that'll be a negative 1 for S. And then for our last line, line T here, if I start from this point and go up to that point, I'm going to go 1, 2, 3 up, 1, 2, 3, 4 to the right. So it's 3 over 4, and it is negative, so negative 3/4 on that one also. So now we want to be able to, now that we have our slopes down, we can identify which ones are parallel and which ones are perpendicular. So starting with parallel, parallel have to have the same slope. So we can see, well, right here, P and Q both have the same slope. So P is parallel to Q. We also see that R and T, they have the same slope of negative 3/4. So R is parallel to T. For perpendicular slopes, they have to be opposite and reciprocal, or they have to, both the slopes have to multiply to equal negative 1. So positive 1 and negative 1. So since 1 over 1 and you flip that upside down, it's still going to be 1. Positive 1, negative 1 are perpendicular slopes. So P and S are perpendicular. P is perpendicular to S, and then also Q and S are also perpendicular with 1 there and negative 1. So that's Q and S are also perpendicular. Those ones are perpendicular there. These two are parallel. And then number 4 says, tell whether the lines through the given points are parallel, perpendicular, or neither. Justify your answer. And so our justification will really just be our work here as we go through. So what we can do there is find the slope for line 1, find the slope for line 2, just using our subtract the y's over subtracting the x's. So if we're subtracting the y's on line 1, that's the 2 and the 0, we could go 0 minus 2 if I did it with the first one, if I start with the first point minus the second point. And then I would need to do the first point minus the second point for the x's, 2 minus negative 2 below that. Well, that's a double negative, so we're going to get a negative 2 on the top, and then this will become 4 for 2 plus 2 on the bottom. So negative 2 over 4 simplifies to a negative 1/2. And now we need to find the slope of line 2. So again, we can do the same thing with the y's, 4 and a negative 2. So this one I chose to do it this way. I chose to start with the first point. I could have done the 4 minus negative 2, but I chose again, start with the first point, negative 2 minus 4. On the bottom, it's going to have to be first point again, 1 minus 4 on the bottom. And so it's going to give me a negative 6 on top and a negative 3 on the bottom. So negative 6 over negative 3. Well, negative over negative is positive, and 6 divided by 3 is 2. So it's going to be a 2 for that slope. Or we can think of it as 2 over 1. And so as you can see, they are opposite signs, and they are reciprocals of each other. 2 over 1 is the reciprocal of 1 over 2. So that's a perpendicular slope right there. So that's perpendicular because they're opposite reciprocal. Or if you multiply these two, negative 1/2 and the 2 together, you will equal negative 1, like it also says. All right, so here we are with our joke of the day. Why can't a bicycle stand up on its own? You ever think about that? Why can't a bicycle stand up on its own? No, because it's too tired. Too tired. That's a nice play on words. Okay, over on page 90, number 5, it says write an equation of the line passing through point P, which is at 3, negative 2, that is parallel to the equation y equals 2/3 x minus 1. That's in a slope-intercept equation. And then graph the equations of the lines to check that they are parallel. So we'll end this one with graphing the lines on our coordinate plane over here. But first of all, it wants us to write an equation. Now it says parallel right here. That's the key one right there. We need to see that's the key part of this, that it's a line that's parallel to this, which tells us that the slope is going to be the same. It's going to be the same as 2/3. So the equation we're going to have is going to have to start with y equals 2/3 of x. It might have a different number back here. And so we're going to say m is equal to 2/3 for the equation that we're going to do. And we're going to plug it into our y equals mx plus b. We're going to use 3 and negative 2, though, as the x and the y to plug in here, so we find a different b than the negative 1. Because it's got to be different than negative 1, otherwise it's exactly the same line. So we start plugging everything in. So y is negative 2, x is 3, we plug that in, m is the 2/3. So negative 2 equals 2/3 times 3. Now here's where you can cross-cancel 3's there when you're doing 2/3 times 3. So you cross-cancel those, you're left with just 2. So negative 2 equals 2 plus b. That's what we see now. And then we want to get b by itself. So we're going to subtract 2 from both sides. And so that cancels our 2's here, so b is by itself, and it equals -4. b equals -4. So now we can write our equation. It's going to, like I said, it's going to start off with y equals 2/3 x. It has to have the same slope, but instead of -1, it's going to be -4. And so there's our equation for a parallel line to this that's going to pass through this point. So let's go ahead and draw this out. So let's go ahead and draw this one in blue. So we're going to graph this equation starting with the y-intercept, and we always have a starting point, which is our y-intercept in this form, -1. So we're going to plot -1 on our graph right here, 1 below the origin. And then using the slope, you're going to rise 2, run 3 to get to the next point. So rise 2, run 3. We're right here at the ordered pair 3, 1. So we have another point right there. Connect the dots to draw the line through. So there's our one line from this one, and the next one I'll do in red. So -4 is our starting point, so we got to come down to -4. So this was -1, 2, 3, there's -4 here. We got to put a point at that spot. And then same slope, go up 2 and also right 3. So up 2 and right 3 puts us here at 3, -2. And so there's a point there, and we draw our line through there. And you can see, okay, 3, -2, that was that point. So it is going to pass through this point here, and it is parallel, as we can see from our graph. Okay, so here on problem 6, this time it says write an equation of the line passing through point P that is perpendicular to our equation y equals 2x plus 3. And then we're also going to graph them on the coordinate plane to check that they are perpendicular. So the key word this time is perpendicular. The lines have to be perpendicular, which means their slopes are not going to be the same. They're going to be opposite and reciprocal of this slope. So this slope is 2. The slope we need to use to write our equation is opposite reciprocal of that. So you may want to put a 1 underneath that so you can see how that's going to flip upside down. So how do you flip a number? Well, you just make sure you put always a 1 under a whole number. So now we can take the reciprocal and see that the reciprocal of that's 1/2. But we're going to make it -1/2 because it's got to be opposite and reciprocal. So -1/2 is the slope of the line that we need to write. Another way you can kind of see this is that if you multiply the slope we have here times m equal to 1 to -1, so the two slopes equal -1. You can do this little equation here if you have any trouble. You can just say, well, I just got to divide by 2. -1 divided by 2 is a -1/2. So you can kind of set up that little equation. The slope you have times m equals a -1. That's how easy way to do it. All right, so we're going to look at our y equals mx plus b, where our x and our y point, again, is up here from point P. So -2 is x, +2 is y. And so we start plugging these numbers into our y equals mx plus b. M is now the -1/2. So all that gets plugged in. And here again, you can cross cancel as we multiply the -1/2 times the -2. These 2's cross cancel. And so negative times negative will be just a +1 right here. So 2 equals 1 plus b. That's what we're going to get now. And now to solve for b, we just got to subtract 1 from both sides. And so 2 minus 1 is 1. So b equals 1. And so now we just use that to write our slope-intercept form equation. Here's the equation of the perpendicular line. Y equals the -1/2. That was the slope we have to use. X, and then plus 1. And so now we want to graph this one and also the 2x plus 3 on this graph. Let's start with the 2x plus 3 here, the original one. I'll do that one in red. And so we start with 3. Remember, our starting point's the y-intercept, so plot 3 on this graph. It's going to be right up there on the y-axis at 3. And then our slope is 2, or 2 over 1. So we're going to rise 2, run 1. So rise 2 and run 1 from there puts us right in here. So it's that slope. So it's doing that, draw the line, and there's our line for the first one. And now for the second one, the blue one, it's going to be +1. So our y-intercept is going to be right there at +1. So we're going to put that point. And then for the next point, you have to go down 1. It's -1 over 2. The negative just got to go with either the rise or the run. I usually stick it with the rise. So -1 over 2. So down 1 and right 2 from here. Down 1, then right 2 puts me on the x-axis at 2 right there. So there's another point. And now we can draw a line through there. And this is definitely perpendicular. So So you can see definitely it's got a perpendicular slope there. They look like a perfect intersection at 90-degree angles then. Okay, so our last problem is going to be similar to this one. Number 7 is going to be similar to this one. I'm showing you this one just because we can see the picture of it. Number 7 doesn't have this picture. We could draw the picture if we want to, and that'd be fine. But it's asking us the same question here as find the distance from the point 1, 0 to the line y equals negative x plus 3. So remember when it's asking for a distance from a point to a line, it has to be perpendicular. So that distance has to be perpendicular to the line. So we can't just go from here to here and say, well, that's 2 from this point up to that point. Well, that's not perpendicular, as you can see. It's going to have to be more over here somewhere to see exactly what the distance of that's going to be. It'll most likely be a decimal. And so that's what we're going to be doing with what we have to do on number 7. We're going to be finding the distance from a point on a coordinate plane to a line here, and it doesn't give us anything else but the equation and the ordered pair. So let's go ahead and take a look at number 7. Okay, so here at number 7, find the distance from point A, which is 0, 5, to the equation y equals negative 3x minus 5. So again, we could plot this and look at the graph of this, but we don't have to find the answer here. Remember when it says find the distance there, it always means a perpendicular line. Has to be perpendicular. A distance is always going to be at a perpendicular line from a point to another line. And so we need to use a perpendicular. We need to basically write an equation for this perpendicular line using this slope here, negative 3. We need an opposite reciprocal slope of that. So it's going to be a positive, because it's negative here, so it's going to be positive. And if we flip 3 upside down, and we can put a 1 underneath it and flip it and make it 1/3. So positive 1/3 is opposite and reciprocal of a negative 3. So we're going to use our y equals mx plus b, and we're going to use the a point there as our x and y. So 0 and 5 are x and y numbers. Negative 3 is our m number to plug it in. We need to figure out what the b is to be able to write this new equation that's a perpendicular line to this one. And so we'll get that. And so we see we got 5 is equal to 1/3 times 0. So we plug in x, that's 0. 1/3 times 0 is still going to be 0. So that makes it pretty easy that b is just going to be 5. So 0, 5, I probably didn't even need to figure that out myself. I just knew that looking at this, whenever x is 0, that's the y-intercept right there, 5. So that's a b. So I could plug that in now and say my equation is y equals 1/3 x plus 5. You might be thinking, okay, why are we doing all of this to find the distance? I haven't seen any distance formula yet. Well, what do we need in order to be able to use the distance formula? We need 2 points, 2 ordered pairs. Well, we only have 1. As you notice right there, we only got A. Well, what's the other ordered pair that we have to get? That would be where these 2 lines would intersect. So we need to find their intersecting points. So we need to find where is this line here and this line now here, because these perpendicular lines, where are the perpendicular lines now going to touch? Where are they going to intersect? At what ordered pair? To do that, we got to go back to Algebra 1, or actually not Algebra 1, but even just earlier when we, Algebra 2. Sorry, Algebra 2 and Algebra 1. When we did systems of equations, we have to use a system of equations to find a point of intersection. So when we have equations like this in slope-intercept form, these are linear equations, and we need to find the point of intersection, that's always going to be a system of equations. And one way we can solve a system is by substitution. Since they both equal y, I can substitute this in for the y that's right here. So negative 3x minus 5, I can plug it in for this y here, and now they both equal each other. So I can write a new equation now, getting rid of the y by substituting this in for y. So negative 3x minus 5 is going to equal the 1/3 x plus 5. And that's now an equation I can solve for x in. Once I find x, I can plug that x back into one of these 2 equations here, probably this one here, to figure out what the y equals. So since it does have a fraction, I'd rather get rid of that fraction. Let's multiply the entire equation by 3 by the denominator of that fraction. So when I multiply it by 3, I can cross out the 3. And so 3 times negative 3 is going to be negative 9x for our first part. This will be a negative 15 equal to just x here, because the 3 now cross-canceled with 3. So x plus positive 15 over on the other side. So that's now our equation after we multiply every term by 3. Now what we want to do is get the x's on one side, these numbers on the other side. So I'm going to subtract x from both sides to bring that over. That cancels the x's here, makes negative 10x on this side. And now I'm going to bring the 15 this way. I'm going to add 15 to both sides. And so it cancels my 15's here. 15 plus 15 is 30. So now I'm going to see a negative 10x is equal to 30. Divide by negative 10. And that's going to give me a negative 3 for an x. So x is equal to negative 3. So now to figure out what the y number of our ordered pair intersecting point is, I got to use this negative 3 and plug it back into one of these two equations. I kind of like this one better. It doesn't have the fraction, but this one's not too bad. We can cross-cancel with 1/3. So it doesn't matter either way. I just decided to use this one up here. If I plug in x, it's going to be negative 3 times negative 3 right there, which gives us positive 9. And so now we're going to see y is equal to 9 minus 5, which is 4. So our ordered pair is negative 3, 4. So that's our intersecting point. So now we have 2 points that I can use to find the distance, because this point is on this line. It's on the line, and it's a perpendicular line to this one as well. So that's why we needed 2 points. We only had the one point, which was A. We didn't have a point. We didn't know where on the line it was going to be perpendicular to. So now we know where it's perpendicular to on this line equation here. I can now use these two ordered pairs to find the distance, and that would then tell me the distance from point A to this line right now here. So we're going to use our distance formula, which, remember what the distance formula is, one big square root. We're going to subtract the x's and square it, plus subtract the y's and square it. So now from these two ordered pairs, we're going to put in our x's. That's going to be a 0 and a negative 3. So we're going to have our big square root, 0 minus negative 3. Well, it's a double negative, changing that 3 to a positive 3. Then it's going to be plus. And then we're going to subtract our y's. 5 and a 4 are the y's here, so 5 minus 4. And so this is going to give me positive 3 squared. This is going to give me 1 squared. So now we have 3 squared, which is 9, 1 squared, which is 1. So we're going to see 9 plus 1, which becomes the square root of 10. Now we don't want to leave the answer as a square root in this one. We do want to round this to like the nearest tenth or hundredth. It doesn't say what to round it to. I mean, if they want you to pick this one, if it's multiple choice, maybe they do have the square roots in it, but let's go ahead and get this as a decimal. So the square root of 10 on a calculator, 10 square root is 3.16. If I want 2 decimal places, I'm going to say 3.16. If I just do 1 decimal place, I'm going to say 3.2. So it really kind of just depends there. What did I put here? I put 1 decimal place, so 3.2. So there's our distance from this point to this line. We have to go a roundabout way to get to that one. We had to first figure out what ordered pair we needed to use to be able to use the distance formula. And to do that, you had to write an equation that's perpendicular to this equation first, and then use systems of equations, set each of them equal to each other since they both equal y, to find that intersecting point to be able to use the distance formula with. Alright, so that concludes our lesson on 3.5, and you want to go on to your assignment now, and we're concluding Chapter 3. We're going to be going on to a quiz very soon, so you want to be ready for that quiz, and I'll see you on the next chapter.